Hello friends, welcome to Bindu Dhadwal chemistry lessons. The topic for today is Arrhenius equation for activation energy. Arrhenius in 1889 developed a mathematical relationship between temperature and the rate constant K is proportional to e raised to power minus EA upon RT. And if we remove the sign of proportionality, we have to put a constant. Let this be A. So equation becomes K is equal to A into E raised to power minus EA upon RT. Here K is the rate constant. A is Arrhenius constant. The whole equation is called Arrhenius equation. The constant of proportionality that is put is called Arrhenius constant. It is also known as the frequency factor. This factor A is related to the number of binary molecular collisions per second per liter. EA is the activation energy, R is the gas constant, and T is the absolute temperature. Taking logs, this equation may be written as, taking logs, we will have ln K is equal to ln A plus ln E raised to power minus EA upon RT. Now taking EA upon RT on the other side of natural log, the equation becomes ln K is equal to ln A minus EA upon RT ln E. But what is ln E? 1. So the equation will become ln K is equal to ln A minus EA upon RT. Now converting to common logarithms, converting to common logs, how does it get converted to common logs? You multiply it with the factor 2.303 and this ln natural log becomes log to the base 10. So this equation will become 2.303 log K is equal to 2.303 log A minus EA upon RT minus EA upon 2.303 R 1 upon T. M, this is X plus this is log A. So Y is equal to mx plus C. This is an equation of straight line. Y is equal to mx plus C. So if we plot log K on the y axis and 1 upon T and 1 upon T on the x axis, we get this graph which is a straight line. The slope of the graph is minus EA upon 2.303 R and the intercept will be log A, the point where this graph meets this axis, y axis. So by knowing the value of the slope and the gas constant R, we can find out the activation energy EA from the slope. Alternatively, we can also use another relation where the factor A is eliminated. The two equations will be ln K1 is equal to ln A minus EA upon RT1. Similarly, ln K2 is equal to ln A minus EA upon RT2. Now, subtracting equation 1 from equation 2, we get ln K2 minus ln K1 is equal to, this cancels out, and we get minus EA upon RT2 minus EA upon RT1. Take ln K2 minus ln K1 is equal to, this is plus EA upon R, common, 1 upon T1 minus 1 upon T2 upon K1, 2.303 we will bring here, is equal to EA upon 2.303 R into T2 minus T1 upon T1 T2. So this is the Arrhenius equation in another form. Now you have to note down the following points in these derivations. Arrhenius equation represents a theoretical equation and gives relationship between temperature and rate constants. This equation is based on two theories, collision theory and reaction rate theory. The factor e raised to power minus EA upon RT corresponds to fraction of molecules which have kinetic energy greater than activation energy. The Arrhenius equation, K is equal to A into e raised to power minus EA upon RT. K is always positive. This means that rate of a chemical reaction, whether exothermic or endothermic, increases with rise in temperature.